Okay, this is a solution to question 4 of the projectile motion questions. The question said a projectile is shot from the edge of a cliff which is 125 metres above the ground, and it has an initial velocity of 50 metres a second, which is 37 degrees above the horizontal at the launch point. So this is the launch point. It's 120 metres above the ground. The vector here is 50 metres a second, so it has a horizontal and a vertical component, which is related to 37 degrees above the horizontal. You need to do this question in 2 parts. The first part is when the ball is above the horizontal, and the second part is when the projectile is below the horizontal. So the first thing we do is resolve the vector into its horizontal and vertical components. So this is part 1, when the projectile is above the horizontal. So we have a Suvat equation here. We have initial velocity, which is minus 30 metres a second, and this is in the vertical direction because Suvat applies to vertical, not horizontal. I've taken downwards as the positive direction, so my acceleration is positive 9.81. My final velocity here is 0, and that's when t will be. So for the whole projectile motion above the horizontal, it will be equal to 2t. So I've used v equals u plus at to find t. That gives minus 30 plus 9.81t. That gives a time of 3.1 seconds to the top. So the total time in part 1 is 6.2 seconds. Okay, part 2. This is when the projectile is below the horizontal, which is that bit. And the vector is kind of the opposite way round to the first part. Horizontal is still going to be the same. That never changes, and the vertical part is just the opposite. So here we are again with a new Suvat equation. We've got S is 125 metres in the positive direction. Again, I've taken downwards as positive direction. I've got 9.81, which is positive. I've got initial velocity of 30, which is also positive downwards, and I don't know v and t. So I'm going to use this equation, s equals ut plus half at squared, to find out the time taken in part 2. So I end up getting a quadratic. Once you've put all the numbers in, substituted in, and you get 2.8 seconds and another number which is negative, which is not used. So therefore the total time in the air is part 1 and part 2, which is 6.2 seconds and 2.8, and that equals 9 seconds. So to work out the distance from the cliff edge, that's what the projectile looks like. We have part 1 and part 2, but in all parts the horizontal velocity is 40 metres a second. That never changes. So it's basically 9 seconds travelling 40 metres a second sideways. So the total distance from the cliff edge is 360 metres. Okay, now we have to find the final velocity to work out the vector component of the projectile when it hits the floor there. So we need to find out v, the final vertical velocity. I'm using a different Suvat. I've used v squared equals u squared plus 2as. Again, downwards is the positive direction. I've got s 125, u is 30, v I don't know, that's what I'm trying to find out, a is 9.81 and t is 2.8 seconds. So v squared equals u squared plus 2as gives me an answer V for 58 meters a second. So we now got a resultant vector when it hits the floor. We've got a horizontal velocity of 40, vertical velocity of 58. Using Pythagoras, that gives us 70.5 meters a second. And using trigonometry gives you an angle of 55 degrees below the horizontal.